substitutional defects and interstitial defects. Similar to that, you can think about, the solid solutions of two types, which is known as substitutional solid solution and interstitial solid solution. So what they are, you if you have understood the things in defects, uh, uh, you know uh, uh, defects definition, then you could have no worry about that, understanding this kind of things, because which is very similar to that. So substitutional means, as you know, what is substitutional defect means, the some foreign element atoms has replaced, okay, the parent element, okay, by taking the place of that. Similar to that, you can think here, you can see, I mean, if you could think that, there's no such black. These all blacks are of other foreign elements. Okay, they have occupied. If they black would not been here, then all the white must be lies in that way. Okay, so if all the white elements, suppose you can think about the white elements is a A, okay, A element, and black is kind of B. Okay, so if you know there's no such impurities and no such incorporation of the other elements, then all the crystals must be in the same fashion as they were in their pure form, like all would be in the very fashion, a very disciplined manner. Okay, but now what happened here, there's some element, though order has not changed, order is the same, as you can see. If you see, the all order has maintained. If you think about the column wise, or it is the row wise, both have maintained the same order. It means the order is same and order has not been disturbed. But what has been disturbed means the places of parent element has been replaced by the foreign element. What you can think, the A is the element, the atom of A has been replaced by the atom of B. Okay, so it could be any places. So the places has replaced. So basically, places has changed. So in place of A, the B has come here. So this kind of the things. If you are having the such alloys, is known as your solid solution of substitutional. Okay, so solid elements replace the solvent atoms in a crystal lattice. It is also having the two types. Okay, so in substitutional solid solution, you are also having the two kinds. What first one is random, okay, and second one is your ordered substitutional solid. So what is random? Random and solid. As you can see here, why it is random? Why it is called random? Because they have placed randomly. Okay, there's no such. Overall, order has maintained. But if we talk about the order of the replaced atom, which is not maintained. This is in this way here, another way here, another. There's no such fashion, right? So there's no such an order has been maintained about their foreign element. But overall, the order has maintained. Okay, as overall order has maintained, but the element that has come into the picture that has not maintained their order. Or you can think about the order. The replacement has not been done fashion orderly. Okay, but in case of, we talk about the order one, then you can see here the same thing happen here also. The replacement of the atoms has been done, but in what sense they have replaced like this. You can see, if what the kind of order they may maintain. Alternately, one atom has replaced. Here is a one. You can see the alternate. Sorry. Yeah, alternate. We think about here the alternate. Here in similar fashion. If we talk about here, so they have maintained the order. Okay, so this is known as your. They have done the same thing, but just it's a difference between the ordered substitution solid and random. It's just being of replacement. How they have replaced the atoms. If they have replaced the atoms in order wise, then it is known as order substitution or solid solution. And if they have not, and they have randomly replaced the atoms, then it is known as your randomly. If we go to the in the definition, so this is your definition. uh, when there is no order, in the substitutional. And there is no order in the substitution of two elements as shown below. The chance of element occupying any particular atomic site in the crystal is equal to the atomic percent of that element in the alloy. In such a case, the concentration of a solute element can vary considerably throughout the lattice structures. The resulting solid solution is called a random or disordered substitutional solid solution. Simple. Okay, so I hope that, I mean, if you this is the kind of the definition that you need to know. Okay, but for understanding what you need to know, you just need to understand what is the definition, what is the sense behind the definition. The sense is that if the replacement has taken place and that replacement is not in order, okay, and not has been done in orderly, then it is known as your random substitutional solid solutions. And just opposite to that, okay, you have the order. You must have the definition like this, what what it is written here, but for the sense you must have to understand what I have already made you know. Okay,